Physics, physics, physics. It's a part of our everyday life, everywhere. You can do real physics in an amusement park. The concepts you will explore using the amusement park as your laboratory are concepts that apply anywhere you go in the universe. You will discover for yourself how meaningful, important, and fun the world of physics really is. There are two big ideas here. See if you can follow what these ideas are. Here's the first one. Can you describe what you feel when you make a sharp turn on a fast roller coaster? Or when you start or stop quickly in a car or on your bike? Speeding up, slowing down, or turning a sharp turn are all examples of change in a state of motion. When your state of motion changes, it's called an acceleration. The only way you, your car, or any object can accelerate in any way is if there is a force applied to the object. Sometimes that force is invisible.
I might be able to help here. The name is Little G-Man. See, I know all about forces, 'cause I work for Mr. Big, Gravity. And he's a force we all reckon with every day. You see, Big G makes the force that you feel as your weight, the force that keeps you here on Earth. Good old gravity.
You mean my weight is a force?
You may not be used to thinking of your weight as a force, but it is. For example, the force of your weight alone can crush things. You jump off a table, you accelerate to the ground thanks to my boss, gravity. For any person, the force of gravity is experienced as their weight. We call this force G-force. Your weight is equal to 1G. Your neighbor's weight, although different, is also equal to 1G. So, how many G's of force are you feeling right now?
Gee.
Right. You should be feeling 1G, your weight.
So things move and accelerate because of forces. One way to measure forces is in units of our weight, or G's.
So what's the big idea? G's, forces, acceleration?
The big idea is that we can actually describe and explain how and why things move.
In the amusement park physics project, you'll be building your own device to discover why and how you move. You'll build an accelerometer. This tool will help you to explore the first big idea. But, didn't you say there were two big ideas?
Yeah. The other one has to do with something completely different. For example, how could you find the height of a flagpole without leaving the ground?
That's where I may be able to help.
Who are you?
You can call me Miss T. T stands for tools.
So, couldn't I just use a huge ruler to measure the height of a flagpole?
Well, it'd be awfully hard to find such a ruler. But I know of some other tools you could use. One is a triangle. First, you use your pace length, the size of your step, to find the distance between you and the flagpole.
How?
Well, let's say every step you take is about 1 meter. Now, if you count the number of steps that it takes to get to the flagpole, then you've got the distance.
Okay. You mean if I take 20 steps at 1 meter per step, then I know I've gone about 20 meters.
Yes. Now, you need to find the angle between your original point and the top of the flagpole. This involves another tool called an altimeter.
Okay, well, I think we're going to be making one of those too.
You can use the altimeter to find the angle.
Okay. Well, it looks like about 45 degrees. So, that's the two new tools that give us distance and an angle. Well, we still don't know the height of the flagpole. Are there some other tools?
Yes, one more to put it all together. Trigonometry. Specifically the tangent ratio.
Oh, yeah. The tangent ratio. That's the ratio of the height to the ground distance. So, with the ground distance, the angle, and the tangent, we can find the height mathematically without ever leaving the ground.
You will discover all these fancy tools in your classroom preparations before you even go to the park. It's pretty easy once you get the hang of it.
So, what's the big idea?
Well, it seems this big idea is that we can make and use tools to answer all kinds of questions about the physical world. In this case, we've got several new tools: pace length, triangle, the altimeter, and tangent ratio. Well, that's pretty cool, because now we can measure all kinds of big stuff.
Yes, and don't forget the accelerometer to measure those G-forces.
You can use all these tools when you do physics at the amusement park, but we have to build and understand them first. Now, let's make an accelerometer so you can measure accelerations you experience in units of G's. You'll need the following items: a Petri dish, G-force scale template, ribbon tether, a piece of foam core, piano wire, tag board tab, a lead weight, and adhesive. The assembly involves some simple steps that we'll show you now. Cut out the paper template and glue it to the inside bottom of the dish with it aligned as shown. Notice these lines register the G-forces you'll feel and measure. You may want to carefully write your name somewhere on the template, out of the way of the scale. Firmly glue the ends of the ribbon wrist tether in one corner to the bottom of the dish and up the side. Like this. This is so you don't lose your accelerometer, in case you're really accelerating. Glue the foam core piece onto the inside bottom of the Petri dish, above the scale template and over the ribbon tether. Make sure to slide the foam core piece to the very top of the dish. Next, put the piano wire into the dish so it aligns with the long line on the template scale and onto the top of the foam core. Make sure it lies over the entire width of the foam core piece. Now, right above the black dot on the template, you can attach the lead weight to the wire. To do this, put a little glue on the weight and then squeeze hard with a pair of pliers to sandwich it into place. Now, glue the wire to the foam core, making sure it's centered and aligned correctly. Apply glue to the wire and foam core, then cover it with the tagboard tab, and you're almost done. Finally, add glue to the inside edge of the Petri dish cover. This is the other piece of the dish that you haven't used yet. Carefully place this onto the Petri dish. Make sure the wire and lead weight are still aligned correctly with the template. After it's dry, we can test your accelerometer. Hold the accelerometer so that the wire and the weight are horizontal, or parallel with the ground. As you stand there just feeling your weight, do you remember how many G's you're feeling? Recall that your weight is equal to 1 g. Hopefully, your accelerometer shows 1 g. Does it work? Try accelerating your accelerometer. Does it register the accelerations? How many g's can you register by moving it up and down? Now don't let go. Now you're ready to measure your changes in state of motion with your own accelerometer. Now, let's make an altimeter to measure angles in the park. If you didn't catch all that, the very easy instructions are in the classroom packet. Now that you've made these powerful tools, let's review the big ideas.
First, we can describe and explain how and why things move.
Remember, whenever something accelerates or changes its state of motion, there must be a force applied to it. With some practice, you can measure forces in terms of g's with your accelerometer. Astronauts experience g-forces when taking off into space, and you too experience g-forces when riding in a roller coaster. In the park, you'll be able to measure just how many g's you feel.
The second big idea, we can make and use tools to answer all kinds of questions about the physical world.
With your pace length, altimeter, and the triangle, you can figure out how tall a Ferris wheel is, how tall a flagpole or a tall building is, and these tools will be handy in a lot of other situations as well. With these ideas and tools, you're ready to do physics in the park while having fun. Physics is all around us. You just have to know how to look.